Okay, this is Wen, and I'm from the PanDA. I'm working on Atlas PanDA system. Today, I will talk about the Globus computer integration with Harvester for PanDA jobs. At first, I would like to introduce what is PanDA. PanDA is a production and distributed analysis system. It's a global workload management system. Currently, it has already been employed in the Atlas experiment, the Ruby experiment, and the Phoenix experiment. Here is a monitor for Atlas. For Atlas, it has more than 100 sites across the world with at a different country and sites. It has generated 450,000 to 500,000 concurrent CPU slots. Here is the PanDA architecture. PanDA centrally manages the jobs, and we have the Harvester. Harvester submit the PanDA jobs to different resources, and then monitor the job status. With the Harvester, we have already integrated a lot of different resources. For example, Grid, Cloud, HPC, Kubernetes cluster, and we also have some integration with the volunteer computing like Blink. Here, the idea for us is to integrate the Globus Compute as a resource provider for PanDA. So we would like to integrate Globus Compute as a resource provider and integrate it to PanDA. In this architecture, we would like the Harvester at first download the jobs from PanDA and then submit the job to Globus Compute. And after that, Harvester will monitor the job status and get the outputs. We expected to use this structure. However, it works for some simple tests. For example, simple for one single function or for one single partial function, it works okay. However, for some complex function in which the user function will call some other user function, with this model, we can only upload the first function. We can't. For the other functions, it's a lot uploaded, so there's some limitation here. So so the idea is we need to shape the user code from local to Globus Compute. The first one is we can register all the other user functions to Globus Compute. However, it's too complicated. The user code can call one function, the other function will call other functions. It's difficult to find the dependency. And another one, for class, it's difficult to share the attributes between different functions. The second way we can use the Globus to container support. However, during the work time, during we are working on this part, the container part was not ready was not ready. So we used the third one. We ship all the user code to Globus Computer within a TAR file. So at first, the PanDA client collects all the user code into one TAR file and sends the TAR file to the PanDA HTTP cache. We install the Harvester at the Globus Computer endpoint node, and the Harvester will download the user TAR file from PanDA cache and pre-install the user code on the Globus Computer endpoint node. So we have implemented this model. It works okay. However, the limitation is the Harvester is required for every Globus Computer endpoint. So here is some test with this integration. We already be able to submit so run some simple functions with or without partial. We are also be able to run some complex machine learning models. And all jobs are submitted from CERN X+ to Autonomous PanDA, then run on one Globus one Globus computer endpoint. Here we found some limitations. At first, for Globus Compute, currently it doesn't have a function to upload a complex user code. So in this model, we installed a harvester to make it work. The container may be a solution if it's fully supported. Another one, we found with the Globus Computer, we can't download the logs from to user part. Without the logs, sometimes it's very difficult to debug. When there are some errors, we cannot get the output, but we do not know what happened. And we also found some other errors. For example, for batch run, we can submit a lot of jobs in one batch, but if one job fails, even all the other jobs finish successfully, the get batch result will raise exception. So it's good. This fact is good. We can get the successful results. Another one, sometimes we try to run some long jobs, and then we found some bug in the code. We would like some function to kill the job. In the future, we still want the harvester to run remotely to use the Globus Compute as a resource provider. So we come up with some new ideas. In this way, PanDA and harvester can start two jobs for a task. The first is the build job. For the build job, it will run a function on the Globus endpoint. Inside the function, it will download the user code from PanDA and install the user code locally on the Globus Compute on the GC endpoint.
We're at about 30 seconds.
Okay, the second function is the execution job. It will call the user function. It's the normal user function. In this model, it requires GC to provide some error to install the user code. We think this model will be useful even GC can support a container. If even GC can support a container, user can use the container as a base. Then the top file can include some specific code, because it's not convenient for user to build a container for every line updates or for debug. And it's also not convenient for physicists who are not familiar with the container to build some containers. Okay, that's all. Thanks.
Thank you. Any questions?
Does Harvester work with containers already? Right?
Yes, we already with this model we already make it work. With this one we haven't started the work.
And are the containers Docker? Are they in Docker Hub or are they Singularity Apptainer?
Did you hear the question?
What's the question?
Ask again.
So are the containers Docker containers? Are they stored in Docker Hub?
Are the containers Docker containers? Are they stored in Docker Hub?
Yes. So before, when this work was done several months ago, at that time container was not supported. Now, if container like Docker can be supported, we can use Docker to ship the user code.
Yeah, if you have Docker containers, we can certainly work with that. We should chat on Slack. I think we can point you in the right direction.
Yes,
very cool. a great opportunity for working together here.
Yes, with Docker, it will be easier to ship the user code.